Hi. In today's video, we'll be going over solving by substitution. So far, we've done a lot with algebraic expressions and algebraic equations. And we're going to keep doing algebraic equations, but this time, we're going to have a little twist. We're going to work with systems of algebraic equations. And what does that mean? It basically means that instead of 1, we're going to have 2. Let's say we were given something like this. 4x minus 3y equals 18, and y equals negative 2. And we were asked to solve for x and y. Now, how would we do that? Either equation on its own does not give us enough to solve for x and y. In this equation, we know that the 4x minus 3y equals 18, but we have no way to simplify. Because, well, if we just solve for x, we'll get a number and y. And if we solve for y, we'll get a number and x. It doesn't help us. But we know that y equals negative 2. So we can write x and then negative 2. But we still need to find x. How do we find x? Well, we use a technique called substitution. What is substitution? Well, basically, whenever you're presented with a system of algebraic equations, you substitute the value of one variable into another equation to find the other variable. Let me show you what I mean. I'm going to plug in negative 2 for y. So I have 4x minus 3 times negative 2 equals 18. I'm going to simplify that out. Negative 3 times negative 2 is 6, so I have 4x plus 6 equals 18. And now, if you remember from last video, this looks an awful lot like a multi-step equation. So, we get rid of addition first. We subtract. 4x equals 12. And then we divide to get rid of multiplication. So we have x equals 3. That's our final answer. We've solved that. Now, that may seem simple. Well, they gave us that x was negative 2. We plugged that in. They gave us that y was negative 2. We plugged that in and we found x. Let's do a little more complicated example. Let's say we're asked to solve a system of equations, but this time we had y equals 6x minus 11, and we had negative 2x minus 3y equals negative 7. Now, in this problem, we're really stuck because we don't know x or y from either of these equations. So what do we do? Well, again, we're going to take this value of y, 6x minus 11, and substitute it in for y, or plug it in for y. So I'm going to have negative 2x minus 3 times 6x minus 11 equals negative 7. Now I notice this looks like a job for the distributive property. So let's do it. Negative 2x, negative 3 times 6, that's negative 18x. Drop down the negative sign. Negative 3 times 11 is negative 33. That equals negative 7. I'm going to rewrite this, combine my two x's, so I have negative 20x. It's actually plus 33 equals negative 7. Once again, I have what looks to be a multi-step equation, and I know the strategy for that. First, I subtract to get rid of addition. I'm going to do it here. And then we're going to divide to get rid of multiplication. So I have x equals 2. There, I have done it. Now, that seems wild. Don't worry. We're going to do a lot more practice with these. The essential strategy is take a value for a variable in one equation and plug it in to find the other variable. Right? So we know y equals all this. That doesn't really help us. But if I can plug this value in terms of x's into my y, I will have the equation that's entirely in terms of x's and numbers, which means I can solve it. If I have a single equation with two different types of variables, I can't. But if I can replace or substitute one of those variables in for another, then I can solve my expression, my equation. So I found x, but I still need to find y. What do? Well, you know what? I substitute again. I go back into my original equation, and I say, oh, y equals 6x minus 11. I'm going to substitute 2 in for x. So that's equal to 6 times 2 minus 11. 6 and 2 is 12, minus 11 is 1. So my final answer is x equals 2, y equals 1. And just like that, I've solved my system of equations. Let's do one more example as practice. So here, let's say we're given something like this. 2x minus 3y equals negative 1. I was also given 2y plus 2 equals 2x. Now, I'm in a bit of a pickle here, because neither of these are exactly in terms of x or y. My other systems that I had something like y equals negative 2, or y equals 6x minus 11. In this case, I don't have anything in terms of a single variable. So my first job is to do just that. Make one of these equations in terms of a single variable. I look at this one and I say, hey, these all have 2 in them. If I were to divide this entire expression, its entire equation by 2, well, I'd be left with y plus 1 equals x. And this is entirely in terms of x. And this is a major breakthrough, because that means I can substitute y plus 1 in for x and have an equation that is entirely in terms of y's. That is really, really good, and I'm going to do that. So I have 2 times y plus 1 minus 3y equals negative 1. I'm going to distribute out. So 2y, bring down the plus sign, plus 2 times 1, which is 2, minus 3y equals negative 1. I'm going to combine like terms. So 2y minus 3y is negative y plus 2 equals negative 1. Then I'm going to get rid of this 2 by subtracting. I have negative y equals negative 3. And now it seems here that if I want to multiply by negative 1 to get y instead of negative y, I'll have that y equals 3. So we've solved one part of our equation. Now what do we have to do? We have to plug this value back in to find x. So again, I'm going to go to this equation. I'm going to take this 3, plug it in for y. 3 plus 1 equals 4, so x equals 4. And just like that, we've solved a pretty big system of equations by substituting. Substituting one variable expression in another problem, or putting one value into a variable, putting a number into a variable, and then finding the result or the number representation of another variable. That is the magic of substitutions. You can take two big complicated equations just by substituting one into the other, and then the value into another. You can find both variables in both those equations. That's all I have. I hope this helped, and I hope you have a great day.